Hello everyone, thank you for joining IIB.com. IIB is offering SQL Server database administration and development. And this chapter 2, we'll see the following key components. The first component that we'll see is defining a problem. When you design a database design, you have to first know what you are going to do. That is identifying a problem. As we tried to mention earlier in chapter 1, after you identify a problem, you have to define the tables that you want to define. What tables you need. So before you do your database design, you have to first know what you are going to do. The next step is you have to define your table. What table what table you need to do your database development. So you have to define your table, and after that, what columns do you need within that table or tables. So you have to identify columns that are called fields. And you have to specify the data type that you are going to store. For example, the age has integer data type. Data type means the type of data that can be stored or that can represent your column, and that is called specifying data type. The next one is, after you specify data type, after you define a column, you have to normalize your table. Normalization is nothing but it is avoiding redundancy within the table. So to avoid redundancy, you have to normalize your table. You have to break your bigger table into smaller pieces. When you do that, your redundancy or repetition within a table will not appear. And after that, you have to specify keys. Keys are unique identifiers within a table. There are primary keys. The primary key is a key that identify uniquely a given table. And there are foreign keys that are keys representing another primary table in the secondary table, and we'll see that in names. And the next one is you have to define a relationship. As I tried to mention, the first step is identifying a problem. After you identify a problem, you have to define your tables. Tables is a set of rows and columns. You have to specify the column name, and you have to specify the data type of that column. And after you define this, what you should do is you have to check this table whether there is a repetition or redundancy or not. If there is a redundancy, what you should do is you have to break this table into 2 or more. And after you do that, you have to specify key. What are the primary key? What is the unique key that identify a given record? As an example, social security number here in US is a primary key that can identify who you are. So that is a primary key. Likewise, you have to identify primary key within your table. And after you identify the primary key, you have to create a relationship between these two tables, the first table and the second table that you brought. And if there is another third table, you have to create a relationship. And after that, you have to draw ER diagram. ER diagram is entity relationship diagram. What you can do is you have to first have a table, and you have to create the relationship between tables. And you have to identify what relationship appear between this table. For example, one table may have one to many relationship. You have to create that relationship using entity relationship diagram. After that, coding is the next step. Now let's see one by one. As we can see here, our problem is to define a student registration system. A student registration system is our problem, just as an example. And then what we need to have a student registration system. That is the next step. The next step is defining a table. So as to have a student registration system, we have to have the following columns. The first one is student ID, first name, last name, age, course number, grade, faculty, and faculty name, faculty head, department name, and department head. So once you define all this, if there is any additional column, just define that and identify or categorize into appropriate table. After you do this, the second step is defining the data type. Okay, we have a student ID. What is the data type for student ID? The data type means the type of data that is stored in the database. So integer is the first one. That means your data type is integer. As an example, 12 is an integer. It's not a character. It's not a string. And when you come to first name, for example, you can take Yosef as an example. Yosef is a character. That means it's a variable character. Variable character means the maximum size is 50, as you can see here, but it can be less than 50. So the same is true for last name and course number. when you come to faculty name, faculty head, department name, department head, all these are variable characters. When you come to age and student ID, it is an integer. Age cannot be a variable character. And when we come to grade, grade can be A, B, C, D, or F. It is one character per record. Because of that, we define here char as an example. If there is sex as an example for student, sex can be char 1. So that is defining a data type. After this, what you should do is we have to normalize this table. As you can see here, we have a student table and we break out the course table from student table. What we did is we first find out course number, course title, credit hour, instructor. As an example, if we have a student information like student ID is 1212, first name is Joseph, last name, and then age. After that, when we come to course name, number, and grade, Joseph may take more than one course. Because of that, we will have redundancy. To avoid that redundancy, we break this table into two, that is a student table and course table. Even beyond this, we can have this kind of table. That means instead of having course number in the same table like a student, because course number and grade will be repeated, so we avoided these two, and then we just create another table. It's called student course. As you can see here, we have course number, a student ID, and grade. So if we have Joseph, I assume that Joseph's ID is 1212, and if Joseph takes Maths 101, and then grade is A, what we can do is simply we can come here, write the course number, student ID, grade. If there is another one, we can do that. And so as to avoid redundancy or repetition, we have to use a primary key of these two columns. If we do primary key of these two columns as a primary key or composite key, that means there will not be any redundancy. That means Joseph cannot take more than one course. And when we come to the second one, it is course table, that's course number, course title, and credit hour, and instructor has the same thing. That is first normal form. So first normal form is avoiding redundancy. To avoid redundancy, we have to break tables into different pieces. And second normal form is avoiding partial dependency. Even though we avoid course number and grade from here, there is partial dependency. For example, faculty name and faculty head are dependent. That means faculty head is dependent on faculty name. Department head is dependent on department name. We have to avoid that kind of approach. So as to avoid this, what we should do is we have to create faculty table separately, department table separately by having faculty ID, faculty name, faculty head as a column name. Same thing for the faculty. And then we have to also create instructor table because that is important. And we already had a student course table. Now that is second normal form. Second normal form means avoiding partial dependency. There shouldn't be a column partially dependent on another column if that table has a primary key. If that is so, you have to break that table into pieces. Now the next one is defining key. Okay, after we do this, actually there are different normalization techniques. Third normal form is there, that is transitional dependency, but right now we'll just focus only on this one. Once we avoid the partial dependency, we have to create keys for every table. Key means unique identifier for a table. A student ID, the key is a student ID. In the course table, course number is the primary key. A student course table, these two can be primary key. If you have more than one primary key, that is called composite key. Composite key is a key, a table having more than one key. And when we come to student, same thing as I tried to mention. Course the same thing, faculty is the same thing, and student course, and instructor, and department or department ID. After having this, what we should do is we need to have a relationship between tables. You have to create. How can we relate a student with student course number? This ID number must be the same as this one. Unless you have a student, it is impossible to register or to give grade for a student. So you must have first a student information, so as to give grade. You must have course number so as to in order to be taken by a student. And the same is true for department ID. Department ID is dependent with department ID, and the faculty ID can be the faculty ID should relate with the department, the faculty ID in the department table. So in here, faculty ID is a foreign key, and in here department ID is a foreign key. Here student ID is a foreign key because it represents this table. If there is a key representing another table, that is called foreign key. So defining a relationship between table is the most important thing. Unless you have a relationship, you cannot have a relational database model. Okay, after we create a relationship, what we should do is we have to start coding. When we start coding, we will see in the chapter 3. But right now, let's summarize. First, we identify problems. Identifying problems means knowing what we do. So before you do anything, you have to identify a problem. In our case, in our scenario, designing a student registration system is the problem. Then we have to define tables. What tables do we need to define? And then we have to identify columns. What columns do we need in that table? And then we have to define data types. What types do you need? What data type do you need to proceed with our we need for columns in our table? Then we have to normalize the table. We have to avoid redundancy. And then we have to specify key, either primary key, foreign key, and then we have to define the relationship between tables. After we do this, the next one is coding. And chapter 3, we'll see how can we start using SQL Server 2012, and we'll see how can we start coding. Thank you very much for joining IOB.com. This is Yosef.